This video is about the CPU and is aimed at letting you be able to answer exam questions about the CPU. So you should be able to state the purpose of the CPU, describe the function of the CPU as fetching and executing instructions stored in memory, and you should be able to explain how common characteristics of CPUs such as clock speed, cache size, and number of cores affect a CPU's performance. Let's start by stating the purpose of the CPU. The CPU, or central processing unit of a computer, is the hardware that executes programs and manages the rest of the hardware. It is often thought of being like the brain of the computer system. Just like your brain gets instructions and data from memory, the CPU gets instructions and data from memory. And just like your brain performs logic and arithmetic operations, so does the CPU perform logic and arithmetic operations. These are the purposes of the CPU. Let's move on to the next point we need to cover, which is to get you to describe the function of the CPU as fetching and executing instructions stored in memory. The CPU follows the fetch, decode, and execute cycle. First, it fetches instructions and data from memory. Then it decodes the instructions which are written in binary code. Then it executes the instruction. Then it fetches instructions and data again. Then it decodes the instructions. Then it executes and carries out those instructions. And it does that again and again and again. And that is the fetch, decode, and execute cycle. You also need to be able to explain how common characteristics of CPUs, such as clock speed, cache size, and number of cores, affect their performance. Now we're going to look at clock speed. So one of the attributes of CPUs you need to understand is clock speeds. Each CPU has a tiny quartz-based clock inside it. For each tick of the quartz clock, the computer carries out just one instruction. The quartz clocks in different CPUs tick at different rates. The rates are measured in cycles per second and are measured in hertz. So how does the clock speed affect the CPU's performance? Well, the quicker the clock speed, i.e. the higher its hertz, the more instructions per second the CPU is carrying out and the better the performance of the computer. And similarly, the lower the clock speed, i.e. the lower its hertz, the less instructions per second are being carried out by the CPU and the lower the performance of the computer. The next characteristic of CPUs, which can affect their performance, which I'll talk about, will be cache size. So the CPU follows the fetch, decode, and execute cycle and is incredibly quick in doing so. A computer at home might have a clock speed of 2 gigahertz, which means it's fetching and executing 2 billion instructions per second. As the CPU is so incredibly quick, it can't actually fetch the instructions from the RAM quick enough, and it certainly can't access the memories from the hard drive quick enough. To get around this problem, it has cache memory. Cache is a special type of memory. It's much quicker for the CPU to access than RAM. And the cache stores often used instructions for a short period of time. This means it doesn't have to spend quite so long looking in the RAM or the hard drive for the instructions or data for it to carry out. So how can cache size affect a CPU's performance? Well, the larger the cache size, the better for computer performance. Why? Because more instructions and data can be stored closer to the CPU and so can be accessed quicker, so it can carry out the fetch, decode, and execute cycle quicker. And similarly, the smaller the cache size, the worse the computer performance, because less instructions and data can be stored closer to the CPU, and so Information is accessed slower because it's got to get more information from the RAM or the hard disk, which takes longer for it to do. Computers only have a small amount of cache memory as it's so very, very expensive. A home computer might only have 3 or 4 megabytes of cache memory. The last characteristic of CPUs, central processing units, which affect their performance, I'm going to talk about is going to be the number of cores. By number of cores, we basically mean the number of CPUs. Single core means there's one CPU. Dual core means there's 2 CPUs in the computer system, and quad core means there's 4 CPUs. So how can the number of cores affect their performance? Well, imagine the computer needs to dig a hole, and each core is a man with a shovel. The more cores you have, it's a bit like having more people with shovels, so you're going to dig your hole quicker. Different CPUs can work on different jobs at the same time, so it really increases the speed and the performance of the computer. It works best when the computer's running different programs, because sometimes if it's only running one program, it's hard to split that up between 4 CPUs depending on the software and the program that's running. So, to quickly recap, the CPU is like the brain of the computer and is made up of the main memory, RAM, random access memory, the processor, and cache memory. The purpose of the CPU is to process data and fetch and execute instructions stored in memory. The CPU carries out the fetch, decode, execute cycle, where it fetches instructions and data, which are written in binary code, from the memory, be it the RAM or the cache memory. It decodes those instructions, then it executes them, and then it does that cycle again and again. The performance of the CPU could be affected by clock speed. Clock speed is measured in hertz, which means cycles per second, and that means how many instructions the CPU is fetching, decoding, and executing. The higher the clock speed, the better performance, as more instructions are being fetched and executed per second. CPU is also affected by cache size. Cache size is a very small, maybe 2 megabytes worth of memory, which is very expensive but very quick to fetch instructions from. And because frequently used instructions are stored there, it's a lot quicker because less instructions need to be fetched from the RAM. The performance of the CPU is also affected by the number of cores. The more cores, the more processing units within the CPU, but the better the performance, although not all programs can be split between different cores easily.